Here, new emerging technology consists of electrochemical solar cell. Electrochemical solar cell is one of the distinct class of device. The first produce electrochemical energy similar to which is produced in a dye-sensitized photovoltaic cell, and just like dye-sensitized photovoltaic cell, it meets the standard which definition of the photovoltaic cell. So new second uh, class of that photochemical cell or electrochemical cell which is use light incident on the photosensitizer semiconductor or aqueous metal emerge in the electrolytic solution. So here electrochemical cell use of electrochemical solutions that semiconductor or aqueous metal emerge in that electrolytic solution and directly use of that chemical reaction, and that due to that chemical reaction their production of more efficient solar cell. If we consider example to produce hydrogen via hydrolysis of water, just like hydrolysis of water, here the same reaction, just like same reaction takes place, and due to that reaction there is production of uh, efficient solar cell. So dye-sensitized are used to absorb light and create electron hole pair in nanocrystalline titanium dioxide semiconductor. Here, the dye-sensitizer are used for the absorption purpose and formation of the electron hole pair, and that electron hole pair form, and due to that the absorption of energy and conduction of energy takes place. So efficiency of that electrochemical cell is nearly about 7% efficient. Next to that electrochemical cell, there is ultra thin vapor of solar cell. In this ultra thin vapors, we can mold it in any shape and size, which is very thin, and thickness is in the micrometer range, and efficiency is somewhat higher as we use in toys, dresses, many uh, nowadays most of the solar cell are used in this vapor form, in this ultra thin vapor of solar cell. So here the thickness of that solar cell is 45 micrometer. Cell efficiency is about 21 percent. So you can see 21% efficiency means very large. In this anti-reflecting coating are uses low cost deposition technique, use a metal organic titanium or titanium mixed with the sustainable organic additives. Means by the use of low cost deposition techniques, if our chemical deposition, the chemical deposition technique, CBD, chemical bar deposition, are very common techniques for preparing low cost solar cell. So and thickness is also maintained in that deposition. So anti, if we will make anti-reflecting coating, what is anti-reflecting coating? Which prevent the further reflection of your light. The role of anti-reflecting coating is absorbing more light, and which does prevent to loss of light from that surface when incident on glass surface or any other glass surface of solar cell. So anti-reflecting coating are consist of thin layer of dielectric. So anti-reflecting coating, what does the anti-reflecting coating absorb much light, and it prevent to escape back from to the environment. It just light entering into it, which is made up of anti-reflecting coating. It consists of thin layer of dielectric material. Dielectric materials, it made up from the dielectric material and specially chosen thickness of refractive index of interference effect in the coating cause the wave reflected, and the from the top of the surface of anti-reflecting coating. So there is prevention of the reflection of these rays into the atmosphere. It the light incident on the panel that get absorbed and prevent it back to its further atmosphere. So whole light is concentrated on one part and remains into it, and absorption coefficient increases, and more much light can solar cell can absorb. Here you can see the diameter of that ultra thin solar cell, and this is the anti-reflecting coating is present here. And mm, by using that anti-reflecting coating, ultra thin low cost deposition technique is used as metal organic titanium or titanium mixed with the sustainable organic derivatives additives. Next is your environmental aspect. Environmental aspect, if you consider, there is pros and cons. So, in that one, advantage, disadvantage, environmental aspect. So, this is solar energy is cleanest energy and clean form of energy, but the production of that panel, batteries that affect the environmental indirectly. Caution of raw material. The raw material required for the solar cell production is uh, exhaustion of raw material, means the raw material production in the factories, and due to that factories production there is waste material produced, pollution are created, CO2 emission during the fabrication process, CO2 carbon dioxide when factory produce that cells, there is emission of that carbon dioxide. Acidification disposal problem of the hazardous semiconductor material, that in that process we use battery. By the use of battery, uh, there is acidification disposal problems are created, panel also use, and various these environmental aspect or is environmental problem created due to the uh, manufacturing processes. But the good part in this situation is what you are in the spirit of all this environmental concern, all this environmental concern. So solar photovoltaic is one of the cleanest form of energy. So this energy is obtained by using so direct absorbing direct solar rays and convert it to electric form. There is no air pollution, but pollution is only for production of that panel and batteries, not any other form. So as compared to other, just like we consider coal, we obtain energy from coal, but uh, by burning of coal there is uh, production of coal, production of pollution, air pollution uh, observed. So, but in case of the solar cell, there is no pollution regarding to the manufacturing of electricity. By the use of petrol, we have faced the problem of air pollution. Photovoltaic cell cost. So main problem regarding the solar cell is cost. How much the cost? If we want to put setup on our home, but the cost of that setup is somewhat higher, so that the common people does not afford that one. So there is major issue regarding to that solar cell is costing. So here we discuss what are the cell cost, photovoltaic cell cost. PV unit price per peak watt. Uh, PV unit is price per peak watt. How much watt is produced in price is regarding to your how much it produce, how much power output it gives in watt. So, peak watt is the amount of power output. So, I told you power output. The amount of power output a PV module produces at standard test condition of the module operating temperature of 25 degree in full non-time sunshine irradiations are of 1000 watt per square meter. So, all the peak watt is is a measure of that power output. How the power output you got from that absorbing solar radiation, um, and it tested how much it gives output in non-radiating condition in 25 degree or room temperature, you can say room temperature. So how much power output gives in non-radiating condition at particular room temperature, right? So typically 1 kilowatt uh, power, one system produce approximately 16,000 to 2,000 kilowatt per hour energy in the India and Australia. So these are the some measurements regarding to it. The typical 1 kilowatt power system produce approximately 16,000 to 200 kilowatt energy. A typical 2000 watt peak or 2 kilowatt kilowatt solar energy system costing rupees 4 lakh 40,000 including installation will corresponds to the price of rupees 220 watt power per watt power. Right. Solar cost from the 1980s to 2000, how costs are decreasing or increasing. You can see here the worldwide solar PV cost. Firstly, that 200 20 dollar you have to spend in 1980s. So this cost day by day is going to be decreased. Now at 2000, in 2000, there is costing is nearly about $2.5. There has been almost six-fold decline in the price per peak watt of PV module from 1980 to 2000 year. Renewable energy uh, cost trends. So there are various types of renewable energy, and here comparison between the PV, wind, geothermal, solar thermal, and biomass. If you consider cost with respect to your year-wise cost, so this uh, costing related to the wind energy is somewhat less, because but wind energy is not efficient, or in all type of area the wind energy is not present. In particular area seaside wind energy is larger, but in desert area, in uh, other area, the wind energy not efficiently present. So PV, in case of PV cell, costing is nowadays very less. That is 2020. If we consider 2020 to 1980s, the cost is regularly decreasing. So it shows the development of the PV technology or PV system. Uh, there is development and cost effectiveness is present nowadays, and there is decrease in the costing in day by day. And geothermal energy, you can see geothermal energy costing is also higher, because just like PV or a solar cell, there is no clean form, or largest form of energy is your solar cell. All these forms are higher energy. Biomass energy, there is no development in the biomass type of energy. If it's in 1980s and pricing it 2010 to 20, there is no decrease. But in case of your PV, there is increase in the cost, decrease in the costing and day by day. Solar electricity price are today around 30 cent per kilowatt hour, but still 2 to 5 times average residual electricity tariffs. So first one step toward the vision, that is Delhi government had decided to make use of solar power compulsorily for lighting up holdings and the for the street lights. Street lights also run on the solar cell, and also holdings which are required many energy. So this holdings is also there is uh, use of solar energy and solar power. Present PV scenario in India. In terms of overall PV capacity, or in terms of overall installed PV capacity, India comes fourth after Japan, Germany, and US. The largest country of production of solar power is Japan. Japan produces too much energy by using solar power. Germany is also second, and third is US. And after the US, we are the largest production of solar energy, solar power. Fourth in that list, with installed capacity of 110 megawatt. We produce 110 megawatt of energy in the area of photovoltaics. India today is the second largest manufacturer in the world of PV panel based on crystalline solar cell. So the production, in case of industrial production of that unit or solar panel or batteries, the India is uh, second largest manufacturer regarding to the photovoltaic instruments. Industrial production in this area has reached to the level of 111 megawatt per year, which is about 10% of the world total PV production. Whole the total 10% of production itself in the India, and more large um, photovoltaic industries or manufacturer units are present in the India, which in the rank of second. A major drive has also been initiated by the government to export India's PV product system, technology, and service. So, this our government decided to uh, export or uh, manufacturing PV units, PV products, produce system to the international level. Solar photovoltaics plant and equipment has been exported to countries in the Middle East and Africa. Indian PV era vision 2012. A great reason receives plentiful solar radiation. Region like Rajasthan, Gujarat, and Haryana receives sunlight of plenty. Desert area. In desert area, the sun rays are very intense, and that's why in area just like Rajasthan, Gujarat, Haryana receives plenty of sunlight. So, thus the power availability is 20 megawatt hour per kilometer square, kilometer per kilometer square, that source. So large amount of energy we obtained into the that arid region. AREDA is plenty of uh, electrify 18,000 villages by year of 2012, mainly through the solar PV cell. Solar PV cell it consists of nearly 18,000 villages. The 2012 that PV solar system installed. Target have been set for large scale utilization of PV technology by different sector within the next 5 years. Means our target is to install various unit in all type of area with in the upcoming next 5 years, because the non-renewable resources going to be vanished very early, and the alternative form of energy needs to find out, and this alternative forms of energy has to be installed and produce large amount of energy, and the requirement of energy by the means of renewable energy has to be increased. So day by day the manufacturer unit are going to be increases, Industrial production increases, research is also be going to be increases, costing is also decreasing. The um, the price the pricing issue is regarding to our battery. So battery cost or battery use is uh, has to be battery. Next is the light of the at the end of the tunnel. That is nowadays by 2020 global solar output could be 276 terawatt hour, which uh, would equal to 30% of Africa's energy need or 1% of global demand. So there is production of 270 terawatt hours, means very large energy which requirement of 1% of the global demand of Africa. This would replace the output of 75 new coal fire power station. Means you can see that 75 new coal fired power, means you can imagine that 75 if you replace 75 coal power fire power plant, then you can imagine how much energy got from that solar panel, and we can save nature by air pollution. 75 is very large number. The global solar infrastructure would have an investment value of US dollar 75 billion a year. So globally in solar infrastructure invested value is 75 billion. By the 2040, global solar output could be more than 9,000 terawatt hour and or 26% of the expected global demand. Means by the use of solar panels, solar energy, we in future the only remaining energy is your solar energy, and that PV panel installation is taken and 9,000 terawatt energy has been produced in the future. The our target is to 9,000 terawatt of our energy. So you can say 2020 2276 terawatt, but in case of uh, in future 2014, this energy conversion rate is into the 9,000 terawatt per hour or 26% of global. You can imagine 26% of expected global demand. The global demand is very high in respect to energy. But if we install that PV panel in that situation, in by the use of PV panel, 26% of expected energy we can produce, our global demand has been fulfilled, and there is a less uh, air pollution has been taken. If we replace 75 fire power station, then you can imagine the how much energy we produce from that free of cost by solar energy. A report European Photovoltaic Industry Association and Green Space. These are the report taken from the API and Green Space. Green. So, conclusion of our today's lecture is that the key to success of solar energy installation is to use quality components and that have long lifetime and required minimum maintenance. So these solar cell we produce in that solar energy we produce in that case, the panel which required very less time for production, and the maintenance is very less. Maintenance is regarding to your battery, not the panel are long lasting, generally 20 years or 25 years um, uh, lifetime of that panels given by the manufacturer. The future is bright for the continued PV technology dissemination, or the future. In future you can see in 2040 9,000 terawatt energy per hour can be produced. So your future by the use of PV technology is very bright, and this technology will acquire the whole market in the world. PV technology fills a significant need in the supporting electricity. PV technology, what they did, the PV technology fills the significant need in the supplying electricity, creating local jobs and promoting economic development in the rural area, avoiding the external environmental cost associated with the traditional electrical generation of technology, right? All is regarding to your supplying energy, fulfilling the need which required for nowadays the energy requirement is very high. So the alternative technology has to be found and cost effective and very cost, not only the cost but in all respect form of energy, all respect, that is pollution, eco-friendly, such type of things has to be fulfilled by the PV technology. PV technology best alternative for all, because it free of cost, solar radiation is used to earth very large, and these technology are very long lasting and very useful for the purpose fulfilling our energy need. Major power policy reforms and tax incentives will play a major role if all the above said is to be efficiently realized. But this is the major role that tax incentives, that is means when we produce some sale, the production cost in India, there is subsidy, we will get subsidy for the purchasing of PV cell. In that we if we want to mount any solar panel setup on our home appliances, for our appliances, the government give us the subsidy for it, and by the use of the subsidy, costing of that panels is reduced. Some cost you have to pay and some will pay by the government, that is the government scheme, so that the production, so that the use of that PV cell, PV technology at home is to be increased. Government is providing subsidy just because we have to use nowadays agricultural motors that runs on the solar panel. Solar panel are mounted in the your uh, uh, agriculture, and the this motor which run throughout the day which on the solar panel, and that's why, and the efficiency, that's why the costing regarding to the um, other alternative form of energy reduces. So that's all for the our photovoltaics and photovoltaic system, photovoltaic cell and photovoltaic system. Rest of the part we will discuss in the next lecture. Thank you.